Hello everyone and welcome to this video on the Python programming language. So in this video, I will attempt to create a killer optimized stock portfolio using Python. Now, according to Wikipedia, portfolio optimization is the process of selecting the best portfolio out of the set of all portfolios being considered according to some objective. The objective typically maximizes factors such as expected return and minimizes costs like financial risk. Now, before we begin, be sure to hit that like button and that subscribe button and click the bell notification to be notified whenever a new video is uploaded. Also, this video is for educational purposes only, and I am not a financial advisor, so invest at your own discretion. So with all of that being said, I am currently on Google's website. It's called colab.research.google.com, and I'm on it because it makes it really easy to start programming in Python. So all you have to do is go to this website and log in using your Google account and get started writing your Python code. Okay, so to get started writing this code, you're going to want to click on File and click on New Notebook, and a new tab will open up for you, and then eventually a new cell will open up for you as well. All right, so I'm in this cell. So the first thing that I'm going to do is put a small description about the program in comments. So this program optimizes a stock portfolio. Okay, so the idea and plan here is to take data from the New York Stock Exchange, so all of the companies that the New York Stock Exchange has, and then come up with a optimized portfolio using those stock tickers or using those stocks. All right, so let's go ahead and create a new cell by clicking that code button in the top left. And now I want to import the Python libraries. So I'm going to import pandas as PD. I'm going to import numpy as NP, and I'm going to import requests. All right, so now I'm going to run this by clicking this button here to the left, and this will make sure I spelled everything properly. All right, and everything's working. So let's go ahead and create a new cell. And now in this cell, I'm going to load the data. So again, I've gathered this data set. It's full of stock tickers from the New York Stock Exchange with the closing price, and it's about 7 years and some months worth of data, almost 8 years worth of data. Okay, so let's go ahead and just upload that data set. So from google.colab, I'm going to import files. So I'm just going to type files.upload, and this will allow me to upload the file. I'm going to click on choose files, and I'm going to upload this New York Stock Exchange underscore close.csv file. Okay, so this may actually take a little bit of time. Okay, so it's all done. Let's go ahead and create a new cell. And in this cell, I'm going to store the data. So I'm going to create a variable called df and set it equal to pd.read_csv. And I'm going to read in that file that I just now uploaded. So let me go up here and highlight the name and then copy using Control C. I'm just going to come down here and paste it using Control V. And just like that, this will store the data. Okay, so next I need to set the date. So I'm going to set the date as the index. All right, so actually, let me go ahead and just create a new cell really quick. And let me just show you the data frame. I'm going to delete here. Okay, let's create a new cell. Let's show the data frame. So I'm going to type df. Oh, I need to run this first, right? So now let's run this cell, type df, and you can see that we have this date column. And then we have all of the stock tickers here. Okay, so what I'm going to do is I'm going to change that these indices here to the left to be the date. Okay, and then I'm going to get rid of this date column. All right, so let's go ahead and do that just so you guys understand exactly what's going on here. So I'm going to set the date as the index. All right, so in order to do this, just type df and set it equal to df.set_index, and then input pd.dateTimeIndex, and we're going to input the date here. dot values, and that should do it. So let's go ahead and run this, and now let's run this. Okay, and now we can see that the index has the date for the indices. All right, so that looks good. Next, I want to remove the date column. So there's many ways we can do this, but one way that I'm going to do is just by using the drop method. So just type df.drop, and then I'm going to tell it what columns I want it to drop. So I want it to drop the date column, and I need to tell it which axis. So that's going to be columns. So set axis equal to 1, and then I want to do it to this data set. So I'm going to set in place equal to true. All right, and that will remove that date column from the data set. Okay, so let's go ahead and run this. And now let's run this. And just like that, we have removed the date column. Okay, so let's take a look at this data set. We can see that there are 2013 rows of data and 102 columns. All right, so if I scroll over all the way to the right, we'll see a company called ZM, or a stock ticker ZM, and that's for the company Zoom. And we'll see that there are no values for this company. Okay, and that is because this company did not have an initial public offering until 2019. So there will be some missing data in this data set, and you can manipulate the data however you want to. If you want to get rid of all of the missing values, or if you want to keep the missing values, it's all up to you. But this is what I'm doing. I'm going to keep these missing values in my data set here. We can also see companies like Amazon and AMD here. So it looks good. All right, next let's go ahead and create a new cell. And in this cell, I want to get the assets, or really the tickers. And that's just the column names, right? So I'm going to create a variable called assets, and I'm going to set it equal to df.columns. All right, so let's go ahead and run this, and I'm going to use this later on. So let's create a new cell. And now in this cell, I'm going to use a package called PyPortfolio Opt. And this is going to make it really, really easy for us to optimize our portfolio. So just type pip install and then PyPortfolio Opt. All right, so I think that's it. Let's go ahead and run this. And this is going to install. So let's just give it a few seconds. Okay, so it looks like it's done. And I'm going to create a new cell. And now in this cell, it's time to go ahead and get those libraries. So we're going to start to optimize the portfolio. Again, first I'm going to get some of the libraries, right? So from Pi, or Pi, pip, maybe it's pip, 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 Pi portfolio. So it's PYPF optimization, or opt. All right, so pipfopt, I don't know how to pronounce that, but that's what we got there. And then type .efficient underscore frontier, and then I'm going to import the efficient frontier. Okay, so next from that same package, there we go, I'm going to import risk underscore models, and from the same package, I'm going to import expected underscore returns. All right, so let's go ahead and run this. Let's see if I made any spelling mistakes. I didn't. Great, let's create a new cell. Alrighty, now in this cell, I want to calculate the expected annualized returns and the annualized sample covariance matrix, okay, of the daily asset returns. All right, so I'm going to create a variable called mu, which is of course the mean, in mathematics. And I'm going to set it equal to expected underscore returns dot mean underscore historical underscore return. And I'm going to input our data set. All right. And next I'm going to create a variable called S and set it equal to risk underscore models dot sample underscore covariance or cove, and then input df. Okay, and I think that looks good. So this is going to give us the sample covariance matrix here, and this should give us the expected returns. All right, so that looks good. Let's go ahead and just run this for now. All right, excellent. Let's create a new cell, and now in this cell I want to optimize for the maximal Sharpe ratio. Okay, so well, what is a Sharpe ratio? Well, the Sharpe ratio describes how much excess return you receive for the extra volatility you endure for holding a riskier asset. Okay, so let's go ahead and create a variable called EF and set it equal to efficient frontier, and we're going to input mu and S. So this right here will create the efficient frontier object. All right, I'm gonna create a variable called weights, and I'm gonna set it equal to ef dot max underscore Sharpe. So this right here will maximize the Sharpe ratio and get the raw weights. And next, I'm gonna create a variable called cleaned underscore weights and set it equal to ef dot clean underscore weights. So this is just a helper method to clean the raw weights, setting any weights whose absolute values are below the cutoff to 0 and rounding the rest. And this actually can cause some rounding errors, so just be aware of that. Anyways, next we're going to go ahead and print the clean weights. The error won't be off by a lot, so I don't think we have to worry about it too much. And then I want to show the expected return, the volatility, and the Sharpe ratio. So just type ef dot portfolio underscore performance and set verbose equal to true. Okay, so let's go ahead and run this. Oh, look like I have some problems here. So let's see, ef dot clean. Oh, it's not cleaned. It's just going to be clean underscore weight. So let's go ahead and run this again, and now it looks good. So we can see our weights here, right? And all together, they should add up to 1. So let me just go all the way over here. Let's see. So there's a lot of them, right, to go through. So I'm not going to go through every single one of the weights for each of the stock tickers, but as you can see at the end here, for Zoom, we have 0.07737. All right. And we'll see what other ticker is used. We have here mRNA or Moderna. So let's keep going here and let's see how this portfolio would perform. So the expected annual return is 141%, which is really, really good. And then the volatility is 28.4%. And then the Sharpe ratio is 4.90. Okay, usually any Sharpe ratio greater than 1.0 is considered acceptable to good by investors. So this is great. All right, next let's go ahead and create a new cell. And I really want to get the discrete allocations of each share per stock. So I need to install pulp to do this. So just type pip install and then pulp. So let's go ahead and run this. And while that's installing, I'm going to go ahead and create a new cell. And in this cell, I'm going to get the discrete allocation of each share per stock. So from PyPort, or from I just do not like saying this thing. PYPF opt dot discrete allocation. I'm going to import discrete allocation. And also I want to get the latest prices, so I'm going to import that as well. All right, excellent. So I'm going to create a variable called portfolio value. So this will contain how much money in US dollars that I want to put into this portfolio. So let's say I want to put in $5,000. I'll just set it like that there. Next, I need to get the latest price. So latest underscore prices is going to equal get underscore latest underscore prices. And then I'm going to input the data frame. So this right here will get the latest prices for us. And then I'm going to set weights equal to cleaned weights. So clean underscore weights. I think I may have done it up here, but no, I did not. So I had the weights equal here. So now this is going to be cleaned weights. And then I'm going to create a variable called DA, which will be short for discrete allocation. So I'm going to set it equal to discrete allocation. And it's going to input weights, the latest price, or latest underscore prices, and then the total underscore portfolio value will be equal to how much we put in there, which is 5,000. So that's portfolio underscore val. Excellent. So next, let's go ahead and create two more variables. So one will be called allocation, and the other will be called leftover. And let's set it equal to da dot lp underscore portfolio, and this will store the stock allocations in this variable, and then the amount that we have left over in this variable, or the funds that's remaining. Okay, so let's go ahead and show that. So just print discrete allocation, and again we're going to print allocation here, and then I want to print the leftovers, or the funds remaining. So these are basically the amount that's left over from that initial $5,000 into the portfolio that wasn't allocated to the stocks. Okay, so there we go. And let's actually put a $sign here, and I'm just going to put leftover. All right, so let's go ahead and run this. All right, so now we can see our discrete allocation, and we can see how much we have left over after allocating that $5,000. Okay, so with that $5,000, this portfolio, or this program, is telling us to create a portfolio with one CTAS, CTAS, one MAR, MAR, one mRNA. Let me go back. It's telling us to allocate it with one CTAS, and then 10 MAR, 4 mRNA, 11 PTONs, 1 PDD, 6 ROST, and 1 Zoom. Okay, and then of course we have about 5.269943237, all that dollars remaining. Okay, so that looks really good, but maybe you don't know some of these companies, and you want to know the name of the company, and you want to learn a little bit about the company before you invest into said companies, then I think it'd be a good idea to have the company's name as well. So let's go ahead and create a function to get the company's name. Okay, so here we're going to create a function to get the company's name. All right, so I'm going to call this get underscore company and get underscore, let's do company underscore name. And it's going to take in some stock symbol, and then it's going to return that company's name. So you're going to have to kind of trust me here. We're going to use a API from yahoo.com. So just type http://autoc.finance.yahoo.com/autoc ? And then we're going to give it a query equal to the symbol followed by this ampersand, and we're going to set the region equal to 1, and the language will be equal to English or EN. All right, so this here URL is what we're going to use to basically get the name of the company. Okay, so I'm going to create a variable called result and set it equal to request. So I'm going to do request.get, and I want to get that URL that I just created, and I want the JavaScript object notation or JSON from it. All right. Then I'm going to loop through the result. So for R and result set result, if R symbol is equal to the symbol that we input into the function, then I'm going to return R's name. So that's the company name. All right, so let's go ahead and run this. Excellent. Let's create a new cell. And next, I want to get the company's name associated with the stock symbol, but I want to store this into a list. So here I'm just going to put store the company name into a list. So create a variable called company underscore name, and I'm going to set it equal to an empty list for now. And then we're going to loop through the allocation. So for symbol and allocation, I'm going to append to company name. So company underscore name dot append. And what am I going to append? I'm going to append the company's name, and we have a function to get that company's name through the symbol. So we're going to append get underscore company underscore name, and we're going to input that symbol. Okay, and that will give us the company name, just like that. So let's go ahead and run this. Excellent. Let's create a new cell. And now in this cell, I want to get the discrete allocation values. All right. And let's create a list. So discrete underscore allocation underscore list. I'm gonna set this equal to an empty list for now. And then I want to loop through allocation. So for a symbol and allocation, I want to append to discrete underscore allocation list dot append, and I'm going to append allocation dot get get symbol. And really what I could have did, I could just put these in the same for loop, but that's fine. For now, I'm just going to keep them separate. So let's go ahead and run this, and let's create a new cell. All right, so now it's time to finally create the portfolio. And in order to do that, I need to create a data frame for it. So we're going to create a data frame for the portfolio. So let me call this variable portfolio underscore df, portfolio data frame. I'm going to set it equal to pd dot data frame. Okay. and I'm going to give it some columns. So I'm going to set columns equal to, we will give it a company name because that's what we want, right? I want the company name. I want the company's ticker or a symbol. And then I want the discrete the discrete values for the stocks. And what I'm going to do here is I'm actually going to append the portfolio's value here. So discrete value, I'm going to append portfolio underscore val, but I need to make that a string. So just type str and let's input that here. Okay, so let's go ahead and run this. All right, looks like I messed up somewhere. So let's go all the way over here. I need to end my brackets and let's run this. All right, next let's create a new cell. And now everything looks really, really good. So we're going to add data to this portfolio. So just type portfolio underscore df, and company underscore name will be equal to that list that we created, company underscore name, and then portfolio underscore df company ticker. I think I did that with a capital, right? Company underscore ticker. I'm going to set that equal to allocation, and then portfolio underscore df discrete underscore val. Actually, I'm just going to come up here and just copy this using Control C and then pasting it here using Control V. Okay, so I'm going to set that equal to discrete underscore allocation underscore list, and let's run this. All right, so no errors. Let's create a new cell, and now let's show the portfolio. All right, so just type portfolio underscore df. Let's run this and let's see what we get. It looks great. So it looks like we would have one Cintas Corporation. We would have 10 Marriott International Incorporations. We'd have 4 Modernas, 11 Peloton Interactive, 1 Pinduoduo, 6 Ross Stores, and 1 Zoom Video Communications Incorporation or Incorporated. So this would be the portfolio, and this portfolio will give us, or should give us, not will, I'm not gonna say will, it should give us 141% return with an annual volatility of 28.4%. Okay, now again, I'm not going to say will because nothing is sure, nothing's a sure thing, but that's what we would expect with this portfolio. Okay, so just like that, you're done creating this killer portfolio. I hope you all enjoyed this video. I want to give a special thanks to all of the people supporting this channel on patreon.com. If you would like to support this channel as well, I will leave a link to the Patreon page in the description below. Thanks again, and I hope everyone has a great day. See you in the next video.